Okay, we'll get started. In this section, we're going to be talking about two different types of circuits. We're going to be talking about series and parallel circuits, and we're going to be talking about the conceptual side of them. Later in this unit, we're going to talk about the math behind them. So, the first thing is if you have multiple resistors, they can be arranged in series, or in parallel in a circuit, and we're going to talk about each one. Parallel. So first we're going to talk about parallel circuits. So resistors, in a parallel circuit, resistors are placed in side-by-side branches that stem from a junction. So the junction in this case would be this dot right here, and you can see it splits into three different pieces and three different side-by-side resistors. So this is a good example of a parallel circuit right here. So for a parallel circuit, it's very important to think about the voltage and the current and how the voltage and current behaves in a circuit like this. So the first thing is the voltage. So in a parallel circuit, the voltage drop across each resistor is going to be the same as the voltage gain from the battery. So what does that mean? It means whatever comes out of the battery has to be dissipated, or whatever voltage there is supplied by the battery has to be dissipated by each resistor. So for example, like let's say there's 10 volts supplied by this battery. So in each path has to dissipate that full 10 volts. So the voltage drop across each resistor is going to be 10V as well. So again, the voltage in every single branch in a parallel circuit is going to be the same. Now the current's going to behave a little bit differently. So the current is going to come out of the battery and it's going to split into different branches at the junction. It's going to split. In this case, it'll split into three pieces. So again, the current is going to split into three pieces, and the sum of the currents in the resistors is equal to the current flowing out of the battery. So for example, let's say there's 8 ohms flowing out of the battery, or not 8 ohms, 8 amps. So as it goes through each of the resistors, or as it goes through this junction, it's going to split up into each resistor, and it doesn't necessarily have to be equal. So for example, if you have 8 amps coming out of the battery, it might split up into maybe 6 amps goes through this one, and then 1 amp, and then 1 amp. But in any case, in every parallel circuit, whatever comes out of the battery has to be split into, the current's going to split into each of the branches. So again, the sum of each of these has to add up to what comes out of the battery is the important thing. And then the last thing to keep in mind in a parallel circuit is a break in one branch may not completely cause an open circuit. Meaning, if for some reason someone were to come along and like cut this wire right here, so like no current could flow through this part, but current could still get through the other two branches and flow to the other terminal of the battery. So again, if you have a parallel circuit, if it breaks, it's not going to completely fail. If there's other branches, the electric charges have a path that's complete. Okay, that's the voltage. That's how current behaves in a parallel circuit. Now let's look at a series circuit. Here we are. So a series circuit is going to behave a little bit differently. So in a series circuit, resistors are placed one after another in a single branch. So this is a good example of what that looks like. So the voltage behaves differently in a series circuit than a parallel. So in a series circuit, the sum of the voltage drops across all of the resistors is equal to the total voltage from the battery. So let's say the total voltage out of the battery is 9 volts. Sure. So the sum of the voltages, the voltage drops from each resistor has to equal 9. So for example, I'll just give you some numbers. So if there's 9 volts supplied by the battery, maybe 5 volts drops from the first resistor, and then we have 3 volts, and then 1 volt. So all three of these would add to the 9 volts. So again, that's how voltage is going to behave. So whatever is supplied by the battery has to be dissipated by the sum of all of the resistor's voltage drops. So that's how voltage works. Current's going to actually be a little bit simpler. So for a series circuit, there's only one path for the current to take. So the current through each resistor is going to be the same as the current flowing out of the battery. So for example, if we have, say, 3 amps flows out of the battery, you can have 3 amps through every single resistor because there's only one place to flow. For the current to flow, they're all going to have the same current. So that's going to be whatever comes out of the battery. So again, the voltage and current kind of behaves, it's sort of the opposite as in a parallel circuit. And the last thing to keep in mind with a series circuit is if you have a break in the circuit, you have a completely open circuit. For example, if someone were to come along and just like cut this part of the circuit, it's completely open. There's no path for electricity to flow because there's only one path. There's not multiple branches. So that's the idea with a series. So series circuit, how the voltage and current behaves, and then if there's any interruption, it's completely open. There's no way current's going to flow. Okay, last thing, let's see a problem out with for one of these kind of types of problems. All right, so we have a 3 ohm motor and a 2 ohm motor are wired in series to a 16-volt battery. All right, let's draw that out. Doesn't say to, but never a bad idea. So we have, I'll actually draw it over here. So we have a 16-volt battery and we have 2 motors in series like this. So 16 volts, and we have a 3 ohm and we have a 2 ohm. 2 ohm. So A is asking us if we have 3.2 amps flowing through the 3 ohm motor, how much current is flowing through the 2 ohm motor. So this one's fairly straightforward. Remember, if we look at the notes, in a series circuit, the current's the same everywhere. So if there's 3.2 amps flowing through the first resistor, there has to be the same. There's going to be 3.2 amps flowing through the second resistor because the current's all the same in a series. So it's going to be 3.2 amps because we have the same current in a series circuit. Alright, so that's A. B asks us, okay, if we have a 6.4 voltage drop across this 2 ohm motor, so if we have 6.4 volts across the 2 ohm motor, what's the voltage drop across the other resistor? So if we think about the rules for a series circuit, we have 16 volts total. That 16 volts has to be dissipated by some combination of the 2 resistors. So if we have 16 volts total, and then we have 6.4 volts dissipated by this 2 ohm resistor, the remaining voltage, whatever that is, has to be dissipated by the 3 ohm resistor, so it gets dropped to 0 by the time it gets back to the other terminal. So if we have 16 volts, we're just going to subtract the 6.4 volts, and whatever is left over is going to be what actually is going to be experienced by the 3 ohm resistor. So it's just you're subtracting 16 by the 6.4, you get 9.6 volts. Okay, so that's the idea. So again, this was a this was a series circuit, but it would have, if we did a parallel circuit, it would have been the same idea. It would have been, think about what your type of circuit you have, think about what are the rules for how does voltage and current behave, and then do your addition or your subtraction, and that's the idea for this. So again, make sure you have all this written down, and maybe take a second to think about what the differences are between series and parallel. Again, current and voltage in the two kind of behaves in opposite ways. But either way, that's it for now.